Hello to my friends, welcome to GT CAAD. Here we have the pallets, the most common product in manufacturing. Here we have the four different size of the pallet, and the material of the pallet is oak wood. It's the most common material between the trees that we can cut easily. Can you tell me why is the oak most common material between the wood to make these pallets? In this drawing, one of these views is more important because it has a lot of main dimension. I choose this front view because it has more dimension than other views. I want to start with this block of the wood here. It's a rectangular block. The height is 100. Here we have the 80 width and thickness is here 120. Go to the Solidworks, Control N, create a new part. Create a sketch and the top plane. Use the center rectangular. Here you can write 80, press tab key, and 125 is the length here. Go to the extrude. Here you can change the direction to mid plane and change it to height 100 millimeters. Okay, here change the material into oak. In search bar just search OAK. Under the wood folder we have the oak material applied. The color and the material change into oak. Save it. Part number 1. Okay, press Ctrl N to part number 2. I want to show you, I want to model this rectangular wood. It's the base, or all other wood or other wood of the pallet are sitting on this rectangular wood. I can show them. This is the bottom view. We have the three of them, 100, 125 width here, and the length is 800, and the thickness here we have the 20. Okay, the sketch on the top plane, center rectangular. Here is 800 millimeters and the width is 80. Go to the extrude boss base and give it thickness 10 millimeters in a mid plane. Let's check it. I think it's a mid plane. Okay, right click on a material, go to the edit material. As previous order, just write oak and select the material, apply, save it. Part number 2. Okay, the part number 3, we have some wood, 1 2 3 4 5 6 7 number of these wood, rectangular wood is the tops of the pallets that our device are sitting on it. Okay, the thickness here is 20 millimeters. Here the thickness is 20 millimeters. The width is 80, and here the length is 1 meter or 1000 millimeters. Okay, 1000, 20 and 80. Create a sketch on a top plane, center rectangular. Here change the length into 1000, press tab key. Here the width is 80. Okay, let me check. Okay, it's 80. Go to the extrude boss base in the mid plane, the thickness is 20. Okay, change the material to oak. And save it to part number 3. The last part is here. We have rectangular wood and 3 number of it exists in the pallets. Okay, the thickness you can see in the front view is the 20 millimeters. The thickness, the width is 800 millimeters, and about the width here is 125. Okay, 125 in the 800 length and the thickness is 20. Press Ctrl N, create a new part and new 2D sketch on a top plane. Use the center rectangular. The length is 800. The width is 125 millimeters and the thickness is 20. Okay, change the material. In the search toolbar, oak, and save it to part number 4. Okay, our part is finished. Just assembly remain. Okay, we are in assembly environment. We need to insert all components, but let's back to drawing. I need to explain. Okay, here I want to start with this rectangular block of the wood. Also, after that I want to start from the bottom and the top wood. Here we have two woods that are perpendicular located to each other. After that I want to use linear pattern to create other samples component. Okay, just click on the small sign flash. We have some option here. Just insert the component, parts number 1. This block is fixed. Look, when I want to move this block, I can't because it's fixed. Right click on this component and make it float. When you hold and press the left click on this component, it's easy to move around. Okay, here I want to make a relation about the front plane and front plane are in the coincidence mate. Okay, top plane and the top plane of the block coincidence, right plane and right plane. Okay, when I want to move the component, it has the relations about the main plane of the assembly environment. Another component I want to insert, just rotate about the y-axis. Let me check about the length. Go to the evaluate and use the measure and check it. The length is 80. Here is the 80. Here parts number 3. Let's to check it. Go to the evaluate and check the length. Okay, it's 1000 millimeters. This length is 125. Okay, let's check it. 125. Make a relation. This side of the parts number 3 and the block are coincident in the reverse direction here. The top surface of this component and the block are the coincident, and just the final relation are here. Two faces coincident relation. As I said, it's along about the width. Make a relation. This face and this face in reverse direction. It needs to sit on the block here. Also this face. Okay, insert again this component, but I prefer to press and hold Ctrl and just drag these components here. Look, the bottom face and the top face are coincident. Here the peak of this component face are coincident, also the right also. Okay, as I said, I want to use a linear pattern feature in 280 millimeters. We have the 3 sample or 3 number of it. Here we have the distance between them is 280. Also we have this length we need to add to this dimension. It's 80. 80 plus 280 is 360. Okay, I want to show it. Run linear component pattern. It needs to select the direction Here about the width is this block, bottom component, and here top component. As I said, we need to make it 3 of them. Also here we have the 280 plus 80 millimeters. Totally is 360. Okay, we have the 3 block 1, 2, and 3 here. Okay, and the distance between them is 313. Also we need to add 125. Okay, the total distance is 313 plus 125. Go to the assembly. Here use a linear components along this length. The component is here and this, but in the reverse direction. Select reverse direction. As I said, 125 plus 313. Okay, I forgot to select the other block. Just right click and edit, feature, and here component to pattern, select this block here. Here we have the 7 number of these rectangular components, is the toughest components on the pallet, and the distance is 40. Also we have the here length is 80. Totally in a linear pattern offset we need to add 40 plus 80 is 120. Go to the linear pattern. About this length, the component is this rectangular. As I said, we have the 70, but the length is here 4, 40 and 80. 40 plus 80. Okay. In this drawing, I think our assembly is finished. Just here the chamfer remains. All corner or sharp corner need to have the 20 in 45 degrees chamfer. Select the surface, normal to view, create a new sketch on the assembly here. Okay, it's better to create a new sketch in assembly and edit it, and it's easy to re-edit it in future. Here this length is 20 and this length and this length is equal length. Just mirror about the midpoint. Mirror entities here, this sketch about vertical center line. Again click on a mirror and select both about the horizontal center line. Here under the assembly feature, go to the extrude cuts and change its direction to true all. Alright, this palette is finished. If you have any questions, just comment below the video. Thanks for watching.